Hello guys, our title is Echo, the deep learning chatbot. So let me give you a brief introduction of what the project does. We wanted to build a chatbot using natural language processing. We wanted to understand how natural language processing works. So our chatbot name is Echo. What happens is that a user comes in, he gives us input, and it gives the corresponding output based on all the training it went through, training the model went through. So what natural language processing does is that it basically helps the machine learning model to get trained on, like the neural network model, to get trained on how to interpret the human language, like what type of responses to give back when a question is asked. All this type of thing natural language processing does. So we wanted to explore this field, and we chose this project. Our main project goal was to, as I've already said, to understand the concept realm of NLP, just explore the what natural language processing does. And because the subject is neural networks and deep learning, like we've harnessed the power of neural networks, like we built several neural networks with a lot of hyperparameter tuning and everything, and later on built a very accurate model with a very high accuracy. And the main thing we focused in our project goals is that hyperparameter tuning. Hyperparameter tuning is like we tried out different activation functions. We've tried out different number of neurons in the layers. We've tried on experimenting a different number of layers being added to the machine learning model. So these type of things, like we've done a lot of hyperparameter tuning and tried to build a model which was not overfitting, neither underfitting, and was performing very well with a very good accuracy. That was our project. These are our main project goals. So let me explain you the data set a bit. So our data set contains a list of intents. So let me explain you one intent here. One intent is that the tag you can see here is that like the WhatsApp you see here is nothing but the output label that the machine learning model is going to predict. The patterns here, what's up, how are you, are these are the things that the user generally inputs. Based on this, the machine learning model gets trained and predicts the output as WhatsApp, and then later on we'll show the responses as the output for the user. So the tag is nothing but the output label that the machine learning model is predicting, and later on the responses are something which will show to the user based on the output label predicted. So that is about the data set. We have like hundreds of intents like this, each having tag patterns and responses as the fields. So our baseline model architecture was like, we just had input layer as 128 neurons and activation function as rectified linear unit. We've tried using sigmoid, tanh and everything, but the accuracy was kind of low, because I'll let you know regarding why we use ReLU in the next slide. So this was our baseline model. We've used 2 hidden layers for 2 dropout layers and the final output layer, and used the softmax as the activation. So the thing was that we got around 84% accuracy with the first baseline model architecture, which we did in the initial phases. And later on, when we moved on to the our model, which we wanted to increase the accuracy and all, so what we tried to do was we added more layers. We tried to change the number of parameters, as you can see here. We tried to experiment on different functions and different activation functions, and we've extended like rectified linear unit. This is because rectified linear unit understand the non-linear relationship between the data, unlike the models like sigmoid and tanh. So in order to not miss out on the non-linear relationship between the data and to increase the accuracy, we use such an activation function. And dropout is nothing but randomly. It's a regularization technique. Randomly drops out some neurons in order to boost the performance of boost the accuracy of the model. And the softmax is like a common. We straightforwardly use softmax as the output activation function, because it's a multi-class classification, as we have like a set of class labels, and our input label matches to exactly one output, which I'll be explaining you in the next slide. Like basically, if you can see here, we have one hot encoded output label. It's nothing but our input is a bag of words, and it gets the output is mapped to a array called one hot encoded list. It has everything as 0 and only one element as 1, which is our actual output that is getting predicted. So softmax, what it does is it assigns the probability distributions to each of the labels, and the one with the highest probability is considered as 1, and that is considered as the output, which I've showed you before as the tag. So from there, the response will be displayed. Going on to the next slide. This is the project workflow. This is nothing but like we've built the model, we've saved the model, and then we created a Flask-based UI. On the into that, we integrated this model, and the person just goes and just types his input features and get the responses. And regarding the loss function and optimizer, we had used categorical cross entropy because this output activation function was softmax. We had to use the categorical cross entropy because this was the best loss function that we're able to like exactly map with the softmax function, and it's also like a multi-class classification loss function used for multi-class classification. And optimizer we used was Adam optimizer because the learning rate and the steps it takes in the gradient is finding the gradient was actually pretty good, and that's the best optimizer we were able to find. So that's why I used these. And if you can see the result, the baseline results were like 84%, and the next results were like 97%. This is the UI you can see here. The results, like if you ask you a joke, it outputs this and these type of things. So these are all the results. And a future scope is nothing but we try to enhance the user interaction on the like as I try to understand the sentimental analysis and everything. We also like to try to train our model even better and understand more of the activation functions and hyperparameter tuning. Yeah, this is regarding the future scope. And these are few references that we went through. Yeah, we understood a lot from these references and later on worked on our model. Yeah, that's it from my end, guys. Thank you.